Hello everyone. This video is going to be a step-by-step tutorial to how to build an application in Golang using Chi router and MongoDB as a database. We are going to build a very simple CRUD application, and we are going to use some design patterns like factory patterns so that whatever instances we are creating, they can be expanded, and we are going to use singleton patterns so that the instance which we will create, we can reuse it. To start with the project, create a new directory called go_crud_app, and to initialize it, use go mod init go_crud_app. So this will initialize a module, and then we are going to need three libraries in our project. So one, we are going to use this go.env to read the environment file. Then we need one MongoDB Golang driver, which is created by MongoDB to connect with our MongoDB. The last one is G. So this is a router which we are going to use to create our CRUD operations like post, get, put, and delete. Okay, let's install them. So for that, come to zoho go.env. Okay, and just copy this path, and we can simply go get go.env. Then this link go Mongo Go driver. So from here we can install the Mongo driver. And the last one, we have to install the G. Okay, so now our dependencies are now installed. So what we can do is like we can create a directory structure. So we'll need one main.go, our starting point. Okay, and it can have package main, function main as our starting point. Okay, and we'll need all our logic to be placed somewhere. So for that we are going to use a directory called use case. We need one directory for our databases operation, so that we will call repository. Okay, and to save the schema of the database, we will use model folder, and whatever request and response we will use, so that we will put it in a DTO folder. Okay, so yeah, so this is it. So let's first create a basic server to check if everything is working fine or not. So for that we'll focus on our documentation only. Okay, so under G we'll have the examples, so let's just simply copy paste it, and here we can see I'll just tell you what we are doing. So in the first line, we are creating a new instance of the router. Then the Chi provides a lot of middleware. So one middleware which we are going to use is logger. So what this logger will tell is like when a request will start and end. So it will tell the few basic things like how much time that particular repair took and all those things. Okay. Now when we will define a route, so we'll use r dot then whatever method you want. So we want a get method for that. Then comes the route, so we want a slash route. Okay, let's just say health. Okay, and then the handler function we have to write. So the handler function signature is like this: the first argument is a response writer and the second argument is the request. Okay, and then inside it we can do we can write a response. So let's simply write and it will take a byte. Okay, and simply say server is healthy. Okay, in this way, and we can simply remove this particular one. So now we have a simple route available, and this particular router is going to listen and serve on the 4444 route. Okay, so this is the very basic server which we have created. Now to run it, we can simply run go run main.go. Okay, so to test it, what we can do, we can just create another terminal and use curl localhost 4444 slash health, and as we can see it is saying server is healthy, so our chi router is working. Okay, now as you can see the information here, so the date, the get method, what is the path, the http version, and from where it came and how much time it took. Okay, so it took 25 microseconds, and it is status is 200 and all those things. So this information is coming from this middleware.logger. Okay, so let's just stop it and we can proceed. The next thing we can do is like we can create a schema for our database. So under the model, create a file called user.go, and here the package will be the model, and we can have type user of struct type. Okay, and we can have fields like id, and the type of the id going to be primitive dot object id. I'll tell you why we need it. Then the next one is going to be a name of string type, age of int, and the last one we can have like a country. Okay, so this is going to be our very simple schema where we are going to save all the user which have name, age, and country, and to have the uniqueness we'll have a id. So this particular id we are not going to generate. We will use the uh, we'll use this particular id field from the MongoDB. So MongoDB maintain its own id which it create on its own. So we are going to reuse it instead of creating another one. These fields are for Golang. So to make it understand for MongoDB, we have to create a mapping called tags, using tags. So we can have bsum. Okay, so this is the format which MongoDB understand. Okay, it is very similar to JSON but not. Then we can have underscore id, and if it is not there we will simply say omit empty. Okay, so what does it mean? So it means like whenever there is a id field, underscore id field in the MongoDB, and when we will try to read it, so map it to the id field. Okay, and same for the other way around, like when we want to save the user or update the user in the MongoDB. So that time map this particular ID field to underscore ID. Okay, so this is for the bson part. Okay, now to generate all the fields, we can have a shortcut. What we can do, simply select everything and select this add tags to struct fields. So it will auto generate everything. So it has generated everything in JSON. So we can simply use simply rename it to bson in the same way. Okay. The next step is we are going to create a data layer or DB layer. So for that, inside the repository, we'll first going to create the interfaces. Okay, so have the user interface dot go. Okay, uh, package repository, a type called user interface of interface type. Okay, so why we need this thing? So, an interface instead of directly creating the MongoDB or like the function is because suppose this is like we are defining, okay, these are the all the functions which we are going to need to have any database operations, like when we will create it in the MongoDB. So you can think like if we are right now using MongoDB, so all the MongoDB instance or the type will just have all these functions to satisfy this user interface. So whenever we'll write a logic, so that time we are not going to directly we'll talk to the MongoDB functions. We'll talk using the user interface. So the advantage here is like in future, suppose you want to change it to suppose MySQL. That time what you can simply do is like you can create a simple MySQL instance, type of MySQL, and then just override or like satisfy all the functions in it, and then you just have to change the reference of that particular database in the way from wherever you are calling, and it will automatically take it. So stay tuned till the end of the video. We'll discuss this more in depth. Okay, so for now just stick with me. So we are going to use a few function called one going to be the create user, and it will accept one user, okay, or we can simply say a type called model.user, okay, and it's going to return a string which is going to be our id, like whatever user is created, so that user's id we will return, okay, and a error. The next method we're going to be like get user by id, and it's going to have a string, and it's going to return model.user or error, okay. The next one going to be get all users. Here we don't need anything, but it will return array of model.user and error. For update method, what we are going to have is like we are going to only update the age, okay. So update user age by id, okay. So this will take two things, one going to be the string for id, and the next one going to be of int for age, and it will also going to return two things, one is going to be the int, and the next one is going to be the error. So why int is like it will tell how many records has been updated, okay. Then we have delete user by id, so id is going to be string, int, and error, same thing, like how many records has been deleted, okay. And the last like delete all user, and it will not take anything, but it will return how many user it has deleted, okay. So this is the interface which we have created, and when we will implement our MongoDB uh, like MongoDB functions, so these are the functions which we are going to you can say override, or we are going to satisfy this user interface, okay. So for that what we can do, we can create a folder inside repository, and we can call it like MongoDB, okay. And inside it we can create another file, suppose user.go, and it can have package MongoDB, and we can have one type going to be Mongo client, okay, struct type, and it will have suppose a client, okay, or the connection to the collection, okay. So to have that thing, we can have mongo dot collection in this way, okay. And now what we can do, we can satisfy all these things, okay. So to satisfy this, what we can do, we can create a function of mongo client create user, and it can accept model.user, and it's going to return string comma error, okay. So we are just right now doing the scaffolding, so let's in the same way we can have for others. We need get user by id, and it's going to be id string, okay. Then get all users, then update user age, going to be age of int type, and it will return integer. Next is delete user by id, okay. And the last one is like delete all users. Okay, so this is the scaffolding of the all the functions which user interface has. So now we can say this Mongo client is satisfying all these functions. So this Mongo client is of user interface type. Okay. So our scaffolding for the database layer is complete. So we'll come here later, and that time we'll just add the logic. So now let's do the scaffolding for our business, where we are going to write the business logic. So for that, inside use case, create a new file called userservice.go. Okay, and we can have a package use case. We are going to define a service called user service. Okay, so this is going to be our entry point for our application. Okay, so you can consider it like whatever operation we are going to do. So we are going to call these user service methods, and then this user service methods will eventually will call our database layer. So there is no direct call to our database layer. Okay, and as we are going to follow this singleton pattern, so what we are going to do is like we'll create the MongoDB connection at the start. Okay, and the same connection then we are going to keep using it. Okay, reusing it, so that will save like the recreating of the connections for each and every request. So for that, what we can have is like we can have a DB client. Okay, and this DB client going to be of repository dot user interface type. Okay, so now we can just simply define our functions or like the scaffolding. All right, so we can have of SRV of service type user service, and we are going to have one function called create user, and this is going to be of handler. Okay, so so handler signature is like it will accept one response writer. Okay, and it will accept one request type in this way. Okay, so this is the signature of create user. So in the same way we can have it for everything. Okay, we can have get user by ID, get all user, update user age by ID, and delete user by ID, and delete all users. Okay, so this is the scaffolding for our user service. So now just let's define our routes. So inside our main.com, so right now we have only one route. So let's quickly define all our routes, and then we can start our main big things like the business logic we are going to write. We are going to create a MongoDB account in the Mongo Atlas, and then we are going to do all the operations there. Okay. So for that, let's just start with dot post, and what we can do is like for a good signature, it should have like API v1. Okay, so it will tell okay which version of the API you are using. So we can have API v1, and then we can have a users. Okay, and it going to use this user service create user. Okay, so for that what we have to need is like we have to first create a user service instance. Okay, so we can have like user service instance, we can say. Okay, so going to be user service use case dot user service. Okay, so for now we are just keeping it empty, so when we will create the MongoDB connection, so that time we will just assign it. So for now we can simply say user service dot create user. Okay, and in the same way we can have then get request, and suppose get all users. Okay, so here we can do one thing. So instead of always writing this API v1 every time, so we can also group it. Okay, so or like we can create a sub router. So to create it, what we can simply do, use r.route. Okay, and the pattern going to be API slash v1. Then we can have our function and all these things. Okay, what we can do, we can simply add it inside it, and we can simply remove this API v1. Okay, So it's just like another way of writing it in much a cleaner way. Okay, and we can even put it inside it. Okay, here. Okay, so here is it. So we have our post request, we have our get request to get all users. We can also have one more request called get slash users, and for our user service dot get user by id. So to get the id, instead of passing it in the body, we are going to use the url. Okay, so we can have a pattern here like id. So whenever something is after this thing, so we'll consider it as id. Okay, and then we will fetch it in our business logic. So this is how we can pass the id in the url. So this is one method. So in the same way, we can have all our pending methods. So for update, we use put method. Okay, and it's going to be like users only. The reason we are having all the signature as user, because their methods are different. So they are like instead of having like okay create user, get user and all. So this is a right way, or like the preferred way to write it, so that your APIs will be look more clean. So here also we can have users service dot update user age by id. Okay, and here also we can send the id in the url param. And the last one going to be delete, going to be users slash id, and we can have users delete user by id, and the last one more delete users, delete all users. Okay, so let's just see if everything is working fine. Yeah. Okay, so far we have created scaffolding of our repository layer, scaffolding of our business logic layer. Okay, so now we are going to write uh, like we are first going to create a MongoDB account in the Mongo Atlas, and then we will create the we'll complete our repository layer. Okay, or this user.go. Okay, so for this tutorial, we are going to use this MongoDB Atlas, which is a cloud database provided by the MongoDB, and it has a very good free tier, which we are going to use. Okay, so search MongoDB Atlas, and you can simply go to anything. Okay, and then you just have to register it if you don't have any account. So I already have one, so I can go and simply do the sign in. We can do this. So when you will register for the first time, so it will ask you the few steps like registering like your name and everything, and it will also ask you to select the tier. So go for the free tier, and it will ask for the region. So select the region which is very near to you, and it will ask like which service you want to use, like you want AWS, Azure or GCP. So all are same, so you can select as per your preference. And once it will create a cluster, it will create a default cluster of cluster 0. Okay, so I'll tell you how to connect with it and everything. So for the connection part, okay, so what we just need first is like we need two things. First we need a database user using which we are going to connect to our cluster. Okay, and for the security perspective, we have to whitelist our network, so that when we will try to connect to this cloud network, so that IP will be allowed. Okay, so let's first go, and under security you can come to network access, and what you can simply do is like add IP address, and you can simply select like add current IP address. Okay, and you can also tell okay if this is temporary or it will delete and all those things. So for I'm going to have this IP deleted in 6 hours 1 day. Okay, and the confirm. So now it will take some time to uh, establish the rule. So meanwhile, what we can do, we can come and create a database access. Okay, we are going to create a new database user. So we can have, like, suppose I'm going to use admin, and for the password you can have password of, like, I'm using a admin at the rate 123. Okay, and then you have to select the built-in role. So we need read and write access to any database for now. Okay, so select that, and yeah, here we are good. Okay, here also, you now this is a new feature game, like if it's going to be a temporary user, or if you want to keep it. So I'll just keep it like, okay, I'm going to have it a temporary user 1 day. That's more than enough. Okay, and if I generate it, okay, so my user is done. Okay, my user is created. So now let's go and see our database. Okay, so here what we can do, we can when you come to database, it will show your cluster. Okay, and you can click it and it will tell you, okay, which region it is. Okay, how many shards. Okay, so there are 3 shards. One is primary, 2 are secondary. So everything is shared in the free access. Okay, and it has a limited size also, or like a limited memory for your thing, like 25 MB or something, I guess, and that's more than enough for our cost. So then on the right top, you can see we have a connect option. So when you connect it, it will show you many options, like how you want to connect. Like we have a compass. So compass is a UI using which you can connect. And then now there is a one good extension also, using which you can connect to MongoDB in VS Code. Okay, but we are going to use drivers, and here you can select the driver of your language. Okay, so we are going to select Go, and it is also telling you, okay, how to quick start. So it will tell you, okay, MongoDB and everything. Okay, install this thing. And so if you don't view the full code, this is the URI, or this connection string, which we have to use to connect to this particular cluster. So as you can see, it has a this is a protocol, MongoDB plus SRV. Okay, then this is the address. So you have to read it like, okay, this is our uh, user which we just created, admin. Okay, then we have to give the password, then to which cluster you want to connect. So this is the cluster ID. Okay, this complete thing. And then these are the you can say the privileges, like what are the things. So we want retry rights. Okay, so it is true, and all these things. Okay, so to see it in the full code, we can go and we'll reuse it instead of writing our own. Okay, so I tell you, I'm going to copy this thing. Okay, and we can have, so inside main.co, so let's have a function called Mongo connection. Okay, and for now let's just test if everything is working fine or not. Okay, so we can simply put it here, everything is fine, or we can simply copy everything. We'll change it later. Okay, so this is it. So just change here your password. So my password is admin123. Okay, okay, everything is fine. We can simply check now. We can simply call this Mongo connection, and if we just say go. Okay, so as we can see, our database connection is successful. So once you'll see this thing, it means like your network is whitelisted, your database user is working, so everything is good there. Okay, so now let's just write it properly. Okay, so the first thing we'll need is like one env file dot env. Okay, and we can have a Mongo URI, and we are going to use this thing instead of here. We'll save it in the env file. Okay, The next thing we need is like a database. So we can have like Mongo underscore DB name. The database name can be like suppose application DB, okay, or simply app DB, okay. And we can have a connect collection. So collection is like if you have no SQL, so it is similar to tables. Okay, so we can have collection name also, and the collection going to be users. Okay, so here the first thing is going to be you to read the environment variable. So you need OS package dot get env and then the your environment variables name. So here we have Mongo URI. Okay, and so by default it will not read it like all this to load this env file. So we now will use our first package which we have installed like go.env, so that we want in the initial part only. So what we can simply do, function init, and then we can simply read go.env, okay, and we are going to load the .env file, okay, and it's going to return an error. So that will read it, and we can say log.fatal as in like error while reading .env. Okay, if everything works, that time we can have a simple message slog.info env loaded successfully. So the one thing here is like we don't want our connection to be closed just after this particular function will end. So we want our connection to be closed when we are exit the application. Okay, so we'll then it means like we have to handle this particular scenario somewhere else. So to do that, what we can simply do, we can return go.client, okay, and it will be like return client, simple. Okay, now one thing to remember here is like this particular thing, okay, as we can see, to check the ping, it kind of tested it on the admin database, okay, but what we want is like we want to test it on our database. So for that, os dot get env, and we can simply has mongo underscore db name, okay. So now this time it will test it to our database, okay, like if it is created or not and all this, like it will if it is created or not and all this thing, okay. So here it is, it will return a client, okay. So we can simply collapse it, and here we have the mongo client, okay. So now here we can have that differ function as in mongo client dot disconnect, and it can have a context of background. That's it. Okay, so this is how we are going to uh, create the MongoDB connection. Okay, so now our user service is ready to, like we have the instance where we can pass. So as we can see, user service accept a DB client, which accept a user repository user interface. Okay, so we have a interface, user interface, and we have a Mongo client which satisfy user interface, and it takes client of mongo.collection. Okay, so what it means is like we have to send a connection to direct to that collection, okay, instead of database. So what we can do, we can create a mongo connection to collection. Okay. So to get that instance of that collection, we have to use Mongo client. Okay, then we have to tell it, okay, which database to connect. So here we are going to use go get env mongo underscore db name. Okay, and one database can have n number of collections, so which particular collection we want to connect. Okay, so for that we are going to use dot collection and then the collection name. So our collection name is mongo underscore collection underscore name. Okay, so this is it. Now we can simply pass it in this way, db client, and it accept a repository user interface. So for that we can have MongoDB, which is inside the repository. You can see MongoDB repository slash MongoDB dot Mongo client collection, or sorry, client and the collection. Here is it. Okay, so this is how we kind of created the connection at once, and then we are going to reuse this connection each and every time. Okay, so this is like we kind of now just now satisfied a singleton pattern. Okay, so now our connection is made to the MongoDB, so we can now complete this scaffolding which we created earlier. Okay, we can implement the logic which will do all the operation, the CRUD operation in the MongoDB. Okay, so let's first start with the create user. So the create will going to be very straightforward. We'll have c dot client. Okay, and then we want to insert the record. So we want to insert only one record, so we'll have insert one. Okay, we can have a simple context dot background, and then we can simply pass the user. Okay, and this particular function will return two things, one result and error. Okay, so result, if you'll see, it is of the insert one result type. Okay, so what it going to return is like the result id if it is succeed. So we'll first handle the error. If there is any error, so return simply call error. Okay, and if everything is fine, so what we have to return is like the id in the string format. Okay, and the MongoDB is returning the id in the primitive dot object id format. Okay, so as we can see, if we just go inside it and see, okay, insert one result. Okay, so this insert id is of interface type. Okay, so we have to convert this interface type first to the primitive dot object id. Okay, so to do that we can simply have result dot insert id dot primitive dot object id. Okay, so now it is converted into object id, and to get the string value, so instead of using string, okay, so what the string will do is like it will convert the object to string. Okay, like it will do the stringify, but we don't want that, we want hex. Okay, and simply return nil as an error. Okay, so it will return a insert id if it is successful. We'll convert first it into the object id, and once it is converted, we'll convert it again to the hex, so that we'll have the id in the string format. Okay, so this is the create user. Get user by id going to be straightforward, as in first the thing is like we are reading, or like we are accepting id in a string format. Okay, but the id which will refer it in the MongoDB is going to be of the primitive type. Okay, so what we can do is like we can first convert the id into the primitive type. So to convert it, it is going to be primitive dot object id from hex. Okay, and the id, and it's going to return the doc id and error. Okay, so if there is any error, that time we'll simply return error as in fmt dot error, a custom error is in like invalid id. Okay, and if everything is fine, so that time we need find one. Okay, c dot client, and we just want to find the one user, so we'll use find one. Okay, it will have the context dot background and it accept a filter. Okay, so let's first have a filter here. So filter going to be of bson dot d type. Okay, so these are the syntax. You just think like these are the language which MongoDB accept or understand. Okay, so we have to create a filter of bson.d. It will accept a key value pair. So the key going to be, sorry, key going to be underscore id. Okay, and it will match to our value. So value going to be doc id. Okay, and we once it will read it or like return from the MongoDB, so it's going to be in the bson format. Okay, this which is like binary serialization format, which MongoDB return. So we have to convert it, or like we have to convert it into the Golang, okay, or the Go struct. So for that we need one structure. So we can have a structure of user uh, model.user. Okay, we want that particular bson to be converted to this user format. Okay, which we already mapped here. So whenever something is returned as underscore id, it will map it to the id. Then we can simply say like, okay, the filter is this thing. Okay, then once there is any record, then decode it to the user in this way, and going to return an error. So let's just handle the error, and if there is any error, that time return model.user and simple error. Okay, so here actually multiple things can happen. Like suppose if error is there, so error can be of multiple type. Like if the record doesn't exist, so that time also it will return something. Okay, so when record doesn't exist, so that time we'll need a proper thing, like a proper information, like okay, record doesn't exist. So for that we can check if error is going to be of mongo, okay, dot error no documents. Okay, so this is of this is the error type, which will check if error is of this particular type or not. If it is of this type, so that time we can return a customized error as like record does not exist. Okay, else if error is not equals to null, that time simply return model.user error. So this is it. Okay, and at last, if everything is works fine, that time we can simply return the user. So this is the user get user by id. Okay, so for get all user, what we can have is like we can have c dot client, and then we want find. Okay, here we can have context dot background and the filter. Okay, so we can have the filter first. Filter is going to be, we want all the user. Okay, so it's going to be of empty in this way. Okay, it means like there is no match required, everything is match filter. Okay, so this time this find, instead of returning all the users, it return a cursor. Okay, or like you can say the address, and we have to read this particular cursor one by one instead of everything at once. Okay, so we'll have a cursor, it will return a cursor, and it will also return an error. Okay, So we'll first check if error is not equals to nil. Okay, so that time we'll simply return. We can, and if there is no error, so that time we have to close the cursor when we will return from this particular function. Okay, so defer cursor dot close, okay, in this way, and it can have a context of it. So see, this is a very critical thing. Okay, you might not find very useful when you are working on a development like your local environment or on a very low scale, but this is a kind of a loophole. I'll try to attach one documentation like why it is very necessary to close the cursor when you are reading the users in the Golang. Okay, so we can now move forward. So we are going to read the cursor by the time there is no record left. So we are going to decode all the cursor into our users. Okay, users model, it's going to have array of model dot user. Okay, so the syntax is like this. We are going to loop over the cursor. Okay, and we'll see if by the time there is any record, it will return true, else it will return false. Okay. Then we can simply have another user of model dot user. Okay, and we can simply decode it, cursor dot decode user. Okay, if there is any error, we'll simply log it and we'll just continue. So log error, the message going to be error while fetching or like decoding get users. Okay, and we can simply have, and we can also log the error in the string format in this way, and we can simply continue, and we can continue. Okay, and if everything works well, that time we can simply append it to users. Okay, so this is it. Okay, let's, okay, so and at the end we can simply return the users in this way. Okay, so this is how we read the cursor for get all user. Okay, and then we have our update user age by id. So here again, where our id is in the string format, so we first have to convert it into the hex format or like the primitive dot object id. So we can simply copy this thing and we can have it here, and we can simply say 0. Okay, so now the update part. So for the update, it's very straightforward. C dot client, and then you can have update one record. Okay, the context. Okay. So now the update takes two things. One is the filter, another is the what you want to update it. Okay, so let's first go with the filter. So we want bson dot t key going to be underscore id, value going to be doc id. Okay, and like update to, we can say, or like update statement. Okay, so update statement, so we what we want, like we want to update age, so we are going to use a keyword called set. So that keyword look like in this way. Sorry, bson.t a key going to be dollar set. Okay, and value going to be like what you want to set. Okay, so here again we have to give a another key value pair. So bson.d. Okay, so we want this particular field, which is age, okay, to this particular value in this way. Okay, so this is our filter, this is our update statement, and we can simply then pass it filter and update statement. Okay, and it will return how many records it has updated, so that we can have in the result, and it will also return the error. So if error is not equals to nil, return 0 comma error. Okay, and if everything is fine, that time we can simply return result dot modified count in this way. So this modified count is of int64, so we are converted into the int format. Okay, so this is the update user by id. So now to just keep everything fast, I can do one thing. We can simply copy the everything, and we can simply paste in the delete user by id, and here we don't need this particular thing. Okay, and our filter can be simply be sounded, sorry, yeah, simply the filter. Here we can simply update it to the delete one. Okay, and you don't require the update statement. Mm, mm, what you return result dot deleted count. Okay, so this is it for delete user by id. For delete all user, it's going to be simply this thing. You can simply remove this particular filter, like delete everything, and here delete many. Here is it. So this is our MongoDB layer is completed here. Okay, so now only one task is pending. So now we just have to connect our user service to this particular repository. So let's finish this also. So but before that, we have to create a DTO layer, like which will tell, okay, what request to accept and what is going to be the response. Like so to create a DTO layer, what we need is like inside the DTO, simply create file called user.go package DTO, and this will define, okay, what request parameters we are going to accept and what response we are going to return. Okay, so for that we can simply have type user request, okay, struct, and it's going to accept a name of string type, age of int type, and country of string type. Okay, and to generate the tags, so yeah, so here again everything here is only understandable by the Golang. Okay, so to map it to the JSON, what we can simply do, add tags to struct fields. Okay, in this way, then we can have similarly user response struct. Okay, so we're going to keep things very simple. We don't want different kind of responses. You can have, like for create, it can have a different response, for get one user, two user, and when you are updating everything. So what we can have is like we can have something called data, and it's going to have interface type. Okay, and then we can simply have one more field called error, which is going to be of string type. That's it, and we can have our tags here also. Okay, data and everything. So this is our simple DTO layer is complete. Okay, so now let's just focus on our user service layer. Okay, where we are going to have all our business logic. So the first thing first, we when we are creating user, so that time we are sending the body with it. So that body we first have to extract from the request. Okay, so what we can have, like extract body from the request. Okay, and so here again everything is in the JSON format. So first we have to convert it into uh, the Golang format. Okay, so what we want, Golang understand the DTO format, DTO.userRequest, which we just created. Okay, so what we need a JSON dot new decoder. So what it has to decode, it has to decode the request. Okay, request dot body, then decode it to what? Decode it to user request in this way. Okay, it will return an error. Let's just handle it. If error is not equals to nil, then we can simply have like as log error, and it's going to be error dot error. And here from here we want to return a response. Okay, so for that we can simply have a response of DTO dot user response. So this is going to be initially the empty response. For error we will update it once, and if there is any error, or if it is successful, that time also we will update it. So if there is any error, so we can have simply error equals to invalid request. Okay, so the thing is like you don't want the complete error to be returned to your response. Okay, so you shouldn't do all this thing in your application layer. You just want to log it, so we have logged it. Okay, and the user or like your API, whoever is using it, they just need like, okay, there is something went wrong with the request. Okay, they don't want the complete picture. So that is, as a developer, it's our responsibility to debug it. So that's why we are putting it here. Okay, so okay, then what we need is like we have to tell if this particular request is successful or not. So we have to set a proper header. Okay, like the response code. So if it is successful, we use 200 as status code. If it is bad request, we use 500. Sorry, yeah, yeah, 500. Okay, so right header, let's see if it is 500 or not. HTTP dot bad request. Okay, sorry, it is 400. Okay, so internal server error is 500. Then we can have JSON dot, we have to now decode it. Sorry, we have decoded the request. Now we have to send the response in the JSON format. So for that we have to encode it. So we want to encode it to what? We want to encode it into the response writer. Okay, and then encode it. What we want to encode? We want to encode our response like this. Okay, and then we can simply return from it. We don't want to continue the request. If everything works well, so we will first have our model dot user. So everything right now in the user request format, which is DTO. Okay, so we want to map it to our repository layers, or like our schema, model schema. Okay, so we can have name, and it's going to be user request dot name. We have age, user request dot age, and country, user country. Okay, and then here we can simply call our DB layer. Okay, so result error. We have our DB layer here, srv.db client create user. It will accept a user. Okay, it will return two things. So if there is any error, okay, so that time we can simply copy paste this thing. We have to tell like error while inserting user in DB. Okay, and here instead of a bad request, we can give internal server error. Okay, so this is like a 500. And if everything goes well, so we can simply have a success message slog.info user successfully insert it, okay, and the ID. So, so now we have to return this ID, so we can do like response.data, we can assign to it, and we can simply now again new encoder code response. Okay, so this is how we are going to create the user in the database. So here many things you can change, just giving you some ideas when you will work on the production environment. Like this particular create user function is kind of very short, that's why I kept everything here. But in the production or like in the real life work, what you can have is like all these things. Okay, from here you can have it, this particular logic in a separate function, like suppose create user, and you can rename this particular function as like create user handler or handle. Okay, so in that way your logic will look much more cleaner and easy to read. And all these things, whatever we wrote inside the error, okay, these things you can create a separate function for it, and you can just send the error object and all the error code also, like which error code you want, and accordingly it will just set everything. Okay, so that also you can do. But yeah, I don't want to make this particular thing complicated here, so just to keep everything simple. Okay, now let's move to the get user by ID. So as you remember, our ID is coming in the URL parameter. Okay, here. So we have to read it. So to read it, we can have, okay, first let's have our response, user response, then extract the ID. So we have G, then you can have the URL param, and then you have to tell, okay, the request parameter, and then you have to tell the key. So our key is ID. Okay, so this ID, okay, this is the key. So suppose if you have here like suppose user underscore ID, so that time you have to give their user underscore ID. Okay, so right now going to be underscore simple ID, it will give the ID. Okay, and then we can have simple validation if ID is equals to empty. Okay, just in case. So that time we'll just say like a message id field is empty, okay? And invalid id bad request, simply send the error. Okay, in this way. Now we'll get one user, one error when we will call service.dbclient.get user by id, and we are going to send the id. Okay, if there is any error, we can simply have error while fetching user from db. Okay, and if everything is successful, slot.info user successfully fetched, small.data goes to user, and json.new encoder encode the response in this way. Okay, so this is it. So we are going to work smartly now, we don't need everything. So get user by id is completed. Now we need to have the get all user. So for get all user we don't need the id, so we'll just remove it. It will return users. So get all users, it will not accept anything. We can simply pluralize it. Here is it. Voila. Okay, so get all users. Now the update user. So for update user again, we can reuse most of our code. So here is it. Okay, so whenever you have the update anything, so that time you can reuse two piece of codes. One which from the get user by ID, or like whenever you are extracting the ID from the URL. So that time you'll need this particular piece of code. Okay, and then comes the update part, like what you want to update. So what you want to update the body. So that time you can reuse the create user methods. Okay, so here we need this piece of code. Okay, like extracting the body from the request. So we can have those two things here in this way. Okay, and now we can simply call update user age by ID, and we want to send the user request dot age, and it will return the result. Okay, error while updating user in DB. Okay, and the last one going to be user successfully updated, going to be result. Good. Okay, so this is our update user by ID. So I'll just explain it once more. We are extracting the ID first from the param. Okay, then whatever body we have sent in the request, okay, which we want to update, like age, suppose earlier it was 15, now we want to 16. So that that body will extract, and later we will just call our update user age by ID, and then simply whatever it will return, we'll handle it accordingly. And at the end, the success. If everything works fine, we'll just return the response. So here we have for update user age by ID. For delete, it's going to be very similar to the get user by ID. So I'm just going to reuse it. Delete user by ID. Everything going to be same here. Only the function name. Delete user by ID. Have it like result. Result error while deleting user from DB. User successfully deleted. Result. And last, delete all users. Okay. Okay. Here. So delete all users. You don't require ID. And users successfully deleted. Okay, I guess we are good here. Yeah, so our service layer is now also completed. Okay, in our main.go everything is fine. Yeah, okay, so I'll just tell you one more thing. Okay, I'll just show you how to do it. Okay, so far now our application is now completed. Okay, so now what we can do, we can simply test it. So to test it, we are going to use the Postman. Okay, so for that we'll first start our server. So let's first have simple message as like server is starting at port 4444. Okay, go run main.go. You can simply run it, and if you can see our env successfully loaded, our deployment is working, and our server is started. So now we can test it. So you can simply open the Postman. Okay, so we can have one request of post type. Okay, so from here you can select the post localhost colon 4444 API slash v1 users. Okay, so inside body you can select the raw, select JSON. Okay, and this is the JSON body which we are going to send. So our name going to be Mando from Mandalorian, age 25, country India. Okay, so Let's see how it works. Okay, so if you can see, it has created the record. It has returned everything, okay, but it is in the text format, but this is the data and this is the ID, and our status is 200, okay, because uh, it is a success. Okay, now let's just see it in our MongoDB also. Okay, so everything is here fine. We can go click on overview, and from here you can have the browse collections. Okay, and once it will start, you can see AppDB, it automatically rated. We don't have to create on our own. Under users, you can see the record is created and its ID is 3383D, okay, which is same as this one. Okay, so the thing is, like, we don't want our records to come in the text format. Okay, we want it to be seen uh, in the JSON format only. Okay, so what we can do, so what we can do here is, like, we can, when we will return it, so that time set its content type as the JSON format. So to do that, what we can do, we are going to use this cheese, one more middleware, g dot, so we can add middleware using r dot use middleware, okay, dot set header. We are going to set the content type of application slash JSON, this particular format. Okay, and now let's just see it again. Now and if you just send, now if you can see, the result is written in the JSON format. Okay, so we created two records, and now let's retrieve it, this particular Ashoka. So fetch user by ID. So what you have to do, localhost colon 4444 API slash v1 users, then you have to give the ID. So this is our ID, and when we hit it, so it is returning everything in the data format. Okay, so as you can observe here is, like, everything is in the caps. Okay, this ID, name, age, country. So this is happening because of our this schema. Okay, it has mapping to bson, but it don't have any mapping to the JSON format. Okay, so to have a mapping to the JSON format, what we can simply have it, like, just select it and simply add the structs for the JSON format. Okay, in this way. And the reason being is, like, inside our DTO, if you can see, we are sending this data using as an interface. So there is no third thing where we are mapping, like, okay, this user should look like this. Okay, so now if we just simply restart our server using Control C, Command C, and if we'll again go to our Postman, if we'll again hit it, now if you can see, everything is changed to the smaller case because it don't had the mapping before. Okay, so now just see fetch all users, API slash v1 users, and if you can see, all users are there, and this time it is an array. Okay, the next one is, like, update user by ID. So let's update it. So for that, we first need the ID, update user, we'll give the ID, and for update we need the put method. Okay, and under raw JSON, just have the age, suppose 35, send it, and we can see this time it returned 1. So what does it mean? It returning 1, it means, like, it modified only one document. Okay, to check, to will again hit it. Okay, so this time it came 0, like, because there is nothing to be changed here because it is already 35. If we just change it again, suppose 44, it again give the data to the 1. Okay, because one document is modified. To check it, we can simply come to fetch all users and fetch all user, and if you can see, the age is 44. So let's just delete the record. For delete, select delete, have the user, and simply send it. It has deleted the one record. If we try to again do it, there is no record present, so it sent like 0. And if you can just simply delete all users, you can say like only one record was left, so it returned 1, another 0. Okay, and if you can see all our logs, so logs are also present. User successfully fetched and updated, last one deleted, and everything. Okay, so yeah, so this is our application, and all our CRUD operation is working. I will add the repository link in the description, and this particular Postman collection also in the description, so you can have it. So thank you for watching, and if you want to see more such videos, detailed one, please comment on which particular technology you want, and yeah, please subscribe, and yeah, thank you.